everyone. I Nilesh Kumar Sen, working as an assistant professor in ABES Engineering College, Ghaziabad. Our today's topic is cache memory organization. Cache memory is a special type of high-speed memory located close to the CPU. Why it is so? It stores frequently used data and instructions so that CPU can access them quickly, so to improve overall speed and efficiency of the computer. Look, actually, what is happening here? See, let us take this is our CPU, and this is our primary memory. Primary memory can be accessed in microseconds, and CPU can perform operations using in nanoseconds. To overcome the time gap, the time lagging, one need to think for a different solution. And to accommodate such time lagging, one need to use some different memory segment, and just because of this, we introduces a newer memory or a segment of a memory that is cache. Some key features of cache memory are speed, as we know that the RAM is faster the main memory, which helps the CPU to retrieve data more quickly. But if we are using cache in between the CPU and the main memory, it will hold the frequently used data or instructions. So initially CPU asks for the cache. If it is found inside the cache, it will directly fetch from the cache memory and need not to contact with the main memory. So it will obvious that it will improve the speed, proximity, since it is located very close to the CPU. Sometimes it is located into the CPU chip itself, L1 and L2. Registers, arithmetic unit, logic unit, control unit, and L1 or sometimes L2 too. Both are available inside CPU or between the cores, and that we'll discuss a few later. And functions, since it temporarily holds data and instructions that the CPU is likely to use again and again sooner. So it minimizes the need to access slower main. What are the role of cache memory? Cache memory plays a very crucial role in our computer system. It provides faster access of buffer between the CPU and the main memory. Primary role of is to reduce the time lagging in between the fetching the instruction from the main memory to the CPU. Benefits of cache memories are faster access, reducing memory latency, lowering burst traffic, increasing effective CPU utilization too. Cache hit and cache miss. There are two important terms while we are studying about cache memory. So cache hit is what? CPU initially finds the required data inside the cache memory. Once it is found inside the cache memory, it will allow for a quick access for that data. On searching in the cache, if data is found, it is considered as a cache hit. And when the data is not found inside the cache memory, then it will look forward for another part or another slower main memory on searching. So it is considered as what? Cache miss. Performance of a cache is measured by the number of cache hits to the number of searches we made. So it is called as what? Hit ratio. It is what the number of cache hits divided by total number of searches that we made. for a particular data or a instruction. Types of cache memory. There are three different types of cache memory is available. That is L1. Sometimes it is also called as internal cache memory, primary cache memory, or level 1 cache memory, or L1 cache memory. It is ranges up to 2 KB to 64 KB. It resides inside the CPU. That is the main term. L2 or level 2 cache memory, that is again a second level of cache memory, which may or may not reside inside the CPU. It may be there or may not be there, but sometimes, or in most of the computer organizations, it acts between the two different cores. That's why we are saying that it may or may not be inside the CPU or outside the CPU. So, and it ranges between 256 KB to 512 KB. And L3 or level 3 cache, that is sometimes it is also known as external cache memory, secondary cache memory, and a level 3 cache memory. It is residing on the motherboard, and it ranges between 1 MB to 8 MB or 16 MB. Now, considering multi-level of cache memory, how it is going to be accessed. Let us consider that we are using two-level cache design. Suppose there is a three mesh in the L1 cache memory, and out of these three meshes, there is two mesh in the L2 cache memory. Then the main memory will be accessed only two times, even though we are saved for the one search. It is clear that here the mesh penalty is reduced considerably than that in the previous case, thereby improving the performance of the cache memory. Let's suppose if we are using only a single cache memory, and all the data which we are searching for is not present inside the cache memory. So all those search or all those hits will be counted as what? The mesh penalty. So we need to access what? The main memory. That is the slower access. That's so to improve the performance, we are using multi-level of cache memory. That if the data is not present in the L1 cache, so might be possible that it may present inside the L2 cache. And if it is two that are not found in to the L2 cache, might be possible that it may present in the L3 cache. And even though that data is not present in all the cache memory, then it is obvious that one need to search for the main memory, and whether it is a slower access, even though we have to use it. What is the average access time for multi-level cache? So average access time, T of average, is calculated as H1 multiplied by C1 whole plus 1 minus of H1 whole multiplied by H2 multiplied by C2. And similar manner, we can also add H3 label. What are H3 and M over here? So H1 is what the hit rate in the L1 cache. H2 is the hit rate in the L2 cache. Similarly, if we are using L3 cache too, so H3 would be considered as hit rate in the L3 cache. C1 is what the time to access information in the L1 cache. C2 is mesh penalty to transfer information from L2 cache to an L1 cache. Since there is a communication in between L1 to L2 and L2 to L3 via very high speed bus. So C1 is what the time required to access the L1 cache to the CPU. C2 is the mesh penalty, so to require transfer data from L2 to L1. And similarly, if we are also using L3, then there would be C3 too. And M is what the mesh penalty to transfer information from the main memory to L2 cache or main memory to L3 cache if we are using. Let us take an example. Find the average memory access time for a processor with a 2 nanosecond clock cycle time, a miss rate of 0.04 misses per instruction, a missed penalty of 25 clock cycles, and a cache access time, including hit detection of one clock cycle. Also assume that the read and write miss penalties are the same and ignore other write stops. So till now, as we discussed, that what is the average memory access time is hit time plus miss rate multiplied by miss penalty. So hit time is what? One clock cycle. So hit time is what? Hit rate multiplied by access time. Hit rate multiplied by access time. What here? Hit time is directly given. So we'll directly use one clock cycle. Miss rate is given with 0.04. Miss penalty is 25 clock cycle. That is the time taken by the above label of memory after the hit. So average memory access time would be 1 plus 0.04 multiplied by 25. So it will give you what? 2 clock cycle. According to question, 1 clock cycle requires 2 nanoseconds. So 2 clock cycles will require how much? 4 nanoseconds. These are the references which are used to create the stuff. Thank you.